Hello, this is section 2.3. We are talking about different measures of central tendency. That's a fancy way of saying what's the middle of the data. Sometimes we want to know what the middle is. You probably heard people talk about the average. We're going to talk about that today. We have a different name for that in statistics. It's called the mean. The mean, this is what you know as the average. And the way you find it is you add up all the numbers and then you divide by how many numbers there are. So for example, if I had a data set of 32, 35, and 39, what I would do is I would add them all up and I would divide by 3 to figure out what the mean is, or the average. So we've got 32 plus 35 plus 39. We're going to divide that by 3 and we get 35.3. That would be the mean of that data set. And what it's doing is kind of roughly figuring out where's the center. And it makes sense, right? Like, think about those numbers: 32, 35, 39. 39 is a little bit farther away, so it pulls that middle away from 35 just a little bit. Should make sense. Your mean or average shouldn't be like 74, right? Because it's trying to find the middle of the data set. The median is the middle number. And the actual physical middle number if you put the data set in order. So in our little sample data set, 32, 35, and 39, those are in order from smallest to biggest. 35 would be the median. It's another way of measuring the middle. If there is no middle number, if there's an even number of data points and there's two middles, so let's say we had 32, 35, 36, and 39, then what you do is you take the middle two and you average them. So I would take 35 plus 36, and since there's two values, I'd divide by 2, and that would be your median. So 35 plus 36 divided by 2 is 35.5. All right, that's how you find your median. And the last measure of central tendency is your mode. The mode is the number that occurs most frequently. Now, there's a couple caveats to this. The first is that if there's more than one, then you list them all. So if you had, say you had two numbers that occurred 5 times, and that was the most often repeated number, you would have 2 modes in that situation. And if they're all the same rate of occurrence, then we say that there's no mode. So one of them has to have more numbers than the other. All right, so in our little sample data set, 32, 35, and 39, you would say that there's no mode because they all occur once. There's not one that's more frequent than the other, okay? But if you had 32, 35, 35, and 39, then you would say that the mode is 35. Now, there are advantages and disadvantages to these different measures of central tendency. The mode, I'm going to be honest, is not used very often because you can find a repeated number that's actually not anywhere near the middle of the data set, and that can happen quite easily. So, for example, I could have a data set that's like 25, 25, and then I'm up here at like 72, 73, 91, 102, right? Most of the data is way up here, and so the middle of the data would make more sense being there, but your mode's going to be 25, which is way off of the middle. So in this situation, the mode is not a good measure. Sometimes the most frequently occurring number does happen to be in the middle, and then that works. But the one that I want to focus on is the difference between the median and the mean. So let's take a look at this data set. And we're going to compare the mean to the median. Let's say we've got 25, 27, 31, 32, and 35. Okay. So if you take these numbers and we find the mean, actually, let me show you how to do this quickly on your calculator while we're doing the problem. On Class Calc, actually, let's do TI first. Where's my TI? So you're going to edit your data into a list. So go into Edit, get into your list, clear it out, and enter your data. So our data set is going to be 25, 27, 31, 32, and 35. Okay. Once you've done that, you're going to go back into Stat. And then you're going to go over to Calculate. So we've been in this edit mode the whole time, but now you're going to select Calculate. And when you get into that menu, you have a couple options. The first one says 1 var stats. This is what you want to select. And then it's going to ask you in the next screen, it's going to say, what's your list? Where did you enter your data? And so for me, I put mine in L1. So again, I'm going to hit second and then that L1 button. And then I'm going to just hit enter, enter, enter. Don't worry about frequency for this one. Frequency list. That's for something else. Leave this blank. And then just hit enter on calculate. And what that will do is kick you back to your main screen, and it'll list out a bunch of stuff. So let's talk about notation. This is for both of my Class Calc and TI people. X bar, this is the notation for the mean or the average. And we'll talk about that more a little bit later, but that is the statistical notation for that. Then if you go down a little bit, there's n equals. This is the number of data points. So like on mine, it says n equals 5 because I entered 5 data points. Then it has, I'm going to slide out of here, out of the screen. It has a minimum. That's going to be minimum value. You can skip the quartile 1. We'll talk about that. A Q1, we'll talk about that later. But if you use your down buttons, you can go median. This is what you want to find for median. Okay. And that's all for the TI. The TI does not do mode. You actually have to go into your list and count and find the mode on that. I could be wrong. It could be hiding somewhere, but I've not seen it. So if you guys find it, let me know. But I think that you have to count it on a TI. On the Class Calc, let's clear out our last data set and let's enter this new data. A equals square bracket 25, 27, 31, 32, and 35. And then you are going to go to stat also right here. And then you're going to go to advanced. And then you're going to go here to 1 var stat. If you don't see advanced, that means you're not in graphing mode on Class Calc. So make sure you tap the upper right hand corner up here and change to graphing. So 1 var stat. And it also wants to know what list you want to calculate. So I tap and hold A, and it gives me all this information. So you can see again, here's your X bar. That's your mean. That's 30. Here's your N, the number of data values. The other things you can see here are min, median, and max. So 31 is going to be our median. And I think, so here's what class calc has. If you go into stats and you're here in basic, you can do mean, median, but you can also do mode, and you can do those separately. The one var stat gives you all of the stats together, but you can do them separately here. So if I hit mode of my list A, then it tells me. Now, what class calc does, typically, because there's no repeats, we would typically say there's no mode. What this is doing is it's listing them all because they're all the same. Your conclusion, though, would be that there's no mode because it's listed all of them. All right, so in our example that we just did, we have the median. Where's our list? Down here. We found out that the median was 30. Or excuse me, the median was 31 and the mean was 30. Okay, they're pretty close. So they're in this data set, they're all a pretty good measure of the middle. Now, watch what happens when I do something like this. Now let's have a set 25, 27, 31, 32, 35, and 105. Now you would look at this data set and say there's something weird happening with this 105. Like, it's not typical, right? Most of the data is between 25 and 35, but then I've got this 105 over here. Look what happens to the measures of central tendency. The middle now here is between 31 and 32, the average of those two middle numbers. So the median is 31.5. Still pretty close to the other measures, right? They're still pretty close to the middle. But look what happens to your mean. If you go back into your data set, I'm doing that really quickly, and I'm going to add this number in here, 105. And then I'm going to calculate my mean. My mean is now 42.5. That's not really, doesn't feel like the middle anymore, right? Because again, you think about a number line, you've got 25 to 35, and then 45 is up here. But it's not the middle of the main part of the data. And so what happens, this right here, this number 105 is what we call an outlier. It's a number that's not typical in relation to the rest of the data. And the mean is affected by the outliers. It gets pulled up because what it's doing is mathematically averaging all those numbers, where the median is just fine in the middle. So that 105 doesn't affect the median very much, but it really affects the mean. So what we would say is it would be better if there are outliers to use the median rather than the mean. All right, all that to illustrate that there's just multiple ways to talk about the center, and it depends on how the data is distributed. Let's talk about some distributions of data. There's a couple words that I want you to know. These are going to be roughly histograms. I'm just going to draw lines just for speed for this. So let's say we have a histogram and like you've got bars that look like this. Something like that. Do you see how the shape of this is roughly kind of a hill, give or take? Okay, like some could be a little bit higher, a little bit lower, but roughly it's a hill shape. This is called what we call a symmetric distribution. We could also have a bunch of data that has a distribution like this. So the bulk of the data is on one side, And then there's a few stragglers out here. Like these we might call as outliers. This is called a skewed data set. And we tell which way it's skewed. And the skew direction depends on where the tail of the data is, not the bulk. So this is the tail side of the data, and that's on the left side of the graph. So this would be called skewed left. Now, in my brain, that feels backwards. I would have named it the other way, but that's how the powers that be decided to name it. So if you have a data set that has heavy data over here, maybe a lot of that, and then it has a couple bars like this, this would be considered skewed right. All right, and then the last vocab word I want you to know is sometimes your data is pretty even all the way across. Like, so maybe it looks like this. Roughly even. This would be called uniform, a uniform distribution. So we'll talk about in the homework, there'll be a couple problems on like what is the symmetry of this data? What does it look? Skewed left, skewed right, symmetric, or uniform? And again, remember, it's general shape. You can have a little bit of variation and we still call it generally these names. All right, and then the last thing in this section is what we call weighted means. It's in this section because it is a type of average, but it's weighted. Now, this is how your grade is calculated in this class. So this is helpful. Most college classes have weighted grades. And so let's talk about what this will look like. So in a class, you might have exams that are worth 20% of your grade, or that's probably not accurate based on a college class. Let's make it 60. Okay, and then maybe your quizzes are worth 20%, and then your final is also worth 20%. Okay, so that's how. So what this means is your exams are worth more of your grade than the other two. They're weighted more. The way that you figure out your final grade is you take the percentage that you get on each of these categories and you multiply by the weight. So let's say you got your scores. Let's say you had, you scored 450 points out of 500. Well, that was your total score on your exams. Maybe your quizzes, you got 20 out of 45. And then on the final, you got an 85 out of 100. Okay, those are the scores that you scored. This is your weight, the weight, and this is dictated by your teacher or the situation. So what you're going to do is, we're just going to do this by hand. You're going to figure out a percentage, find a percent for each of these. So the way you figure that out, remember, is you just divide out your fraction. So you've got 450 divided by 500, and this is going to be 0.9. Actually, let me change this. We don't want a percent. We want a decimal. The calculation's the same, but just don't change it to a percent. So this is going to be a 0.9. So you got a 90% on your exams. The 20 divided by 45, that's going to be a 0.44. So you got a 44% in your quizzes, and then 85 divided by 100 is 0.85. And then the second thing that you're going to do is you want a decimal for each of these. So this is going to be 0.6. We're just moving the decimal 2 to the left, 0.2 and 0.2. And then the last thing that you're going to do is you're going to multiply each category by the weight and add them up. So what I'm going to do here in this calculation is 0.9 times 0.6 plus 0.44 times 0.2 plus 0.85 times 0.2. So this is your exams, this is your quizzes, and this is your finals. So each score times the weight and score times the weight. So this is going to give us 0.9 times 0.6. See, my cat is making an appearance. 2 plus 0.85 times, this is times, and we get 0.798. So that means that your grade, if you're rounding, is an 80% in the class. Okay? So that's how you calculate a weighted mean in your class. So now you can calculate your grade. All right, I will see you next time for the next section. Have a great day.